Hello friends, and welcome to this new session of the Kubernetes cluster architecture. In this session we are going to discuss about the architecture of the Kubernetes cluster. So my name is Alok Kumar and this is the agenda that we are going to discuss in today's video regarding the architecture of the Kubernetes and the control plane component and node plane component. So we are going to discuss on each of the component of the master cluster and the worker node. In the Kubernetes cluster, there is only two components. Okay, the control plane, or you can say the master node. This is used for the management and the control center of the Kubernetes cluster. So in the diagram, you can see the Kubernetes control manager, the Kube API server, etcd, Kube scheduler, and the cloud controller manager, which is the part, but it's considered as a separate component for managing the controller of the cloud. Okay, so the key component of the control plane includes the API server. Okay, it exposes the Kubernetes API, the RESTful API. Okay, because whenever you use the client, suppose the kubectl, to create a pod, all the informations will go to the Kube API server in a REST API way. Okay, so it understands these things and create accordingly the informations, the resources in the Kubernetes cluster and registered all the information into the etcd. So etcd is the component that directly connected with the API server and communicate accordingly. So it's a distributed key value store that is stored the cluster in configurations data. The controller managers manage the controllers, so it have the management of all the things. Okay, so managing the nodes, managing the pods, so all the things. Managing controller responsible for maintaining the desired state of the resources. Okay, so it will manage the according to the replica set, whatever the replica we defined, it's bring that up, and if the node is down, then it will bring another nodes. Okay. Scheduler assign the work container to nodes based on the resource availability and the constraint. Okay, scheduler will come into the picture when we need to deploy a particular container inside a node. Okay, so it will manage all the CPU and the resource allocations. Worker node, this is the worker node, so you can consider it as a 3 nodes where we have the Cubelet, QProxy, and the container runtime, which is the favorite one, is the Docker. Okay, and we have the container T as well. So Cubelet ensures containers are running in a pod on the node. So Cubelet, if you consider it as a SIP, and this is the big SIP, so it's distributing the load accordingly, and Cubelet is responsible and it's a captain of the smaller SIP. Okay, and it reports all the things to the Kube API server. Okay, QProxy is maintained the network rules on the node, so which particular pod and how the pods will communicate with each other in the different node, different namespaces. So all the things will be taken care by the QProxy. And the container runtime we already discussed. Kubernetes API server, it's also known as the Kube API server. So Kube API server is the RESTful. We already discussed that it's a RESTful interface that expose the Kubernetes API. So whenever you use for the interactions, any of the client, you can use it to get the data or to update any images. At that time you are using the API server, and it goes as a REST applications, REST API request. Okay, so once you put a request to get all the pod from the cluster, so at that time it will authenticate and authorize your request, either you are a authentic user or not. So API server authenticates the user and components and enforce the across control policies. Okay, using the RBAC. It ensures that only authorized entity can be performed. So this is the first point of interactions with the Kubernetes master. So every request comes to the Kube API server. Accordingly, Kube API is connected with all the components, and it pass the informations. If some update request information is received, then it will update the etcd, a new resource will created, so it will registered into the etcd. So Cube API is responsible to interact with the etcd. It's also do the validations and the mutations and admissions control. Okay, so if it also automatically inject the sidecar, means the helper container, and enforce the security policies. Versioning supports is also provided by the Cube API server only. Okay, and etcd interactions we already discussed. The Cube API inform all the informations are registered in all the informations to the etcd. So because this is the main database of the Kubernetes server, okay, Kubernetes master component. And if we need to take the backup, then we only take the backup of the etcd. So whatever the informations you get in your console is getting from the etcd only. So we discussed more about the etcd, and we have a particular video on the etcd, which you can see in my playlist as well, where we discussed in more detail about the etcd and also how to take the backup and how to restore it. So etcd is the distributed, consistent and highly available key value store used in the Kubernetes to store critical configurations data. So this is the main component, you can say. By the way, all are the main component, but this is the database. That's why we are mainly concerned with it to take the backup if something or disaster management things. So it's distributed. So we place it in a remote locations, and all the etcd database will be in the sync. So request will go to the any of the etcd database. It's have the consistency nature. Okay, so it will you get the informations from any of the etcd database the same. Okay, because it also provide the consistency. So etcd ensure that the strong consistency, meaning all the client see the same data regardless of which etcd server they connected to. Okay, it's highly available, so you can either have the one etcd or the 3 etcd, 5 etcd database server in distributed environment. So you can also use the etcd to allow the client to set up the watch events, enable them to react to changes in the stored data. Okay, so this feature is crucial for the Kubernetes controller. Okay, and it also supports the atomic transactions, which means that the multiple key value changes can executed as a single unit of work. So all the things will be placed at a time or not. Okay, so if you roll back, all the things will roll back accordingly in case of any problem occurs in the Kubernetes cluster. It's also have the configuration management. It stores the configuration parameters, secrets and other critical data required by Kubernetes components to operate correctly. Now the controller manager, so it control also the pod level, the node level. So all the things will be controlled by the controller manager. It's a component within the Kubernetes control plane, and that is responsible for running and managing the controllers. So it manages the several types of controllers. Okay, so controllers are the control loop that continuously work to bring the current state of the resource in the cluster. Okay, so the key functionality is it's responsible for running the controller, any types of controller. It have the pods, replica, any resources it will control. It's maintain the desired state all the times. Whatever you configured for the desired state, it always try to maintain it. It's also help in the scaling and the load balancing. Okay, so for example, the horizontal pod autoscaler controller adjusts the number of replica of pod based on the CPU and the memory uses. Self-healing, it's have the controller automatically detects and recover from failure. Okay, if a node goes down, the node controller will try to start the node, and all the pods will move at the time to the other nodes or any of the healthy nodes. So in this way, it will manage the moving of the pod from the node and then bring the nodes up. Okay, now the scheduler, we can say that if we request to schedule any particular pod in a particular node, So if you didn't define it, then the scheduler will come into the picture, and it will look into the resources of the nodes as per the resource availability. It just pass the information so that we can do the deployment, or you can put it a particular pod in a particular node. So the key functionality is the node selections. Okay, so it will select the node accordingly, which particular nodes we have to create a particular pod. Okay, the resource management, the affinity and anti-affinity, and these all things we are going to discuss in a more detail. If you refer my videos, then you can find that all things we already discussed in more details about the affinity, anti-affinities rules in the specified in the pod specifications. Okay, load balancer, it helps distribute the loads evenly across the nodes. Okay, taint and tolerations. Suppose we have the Kubernetes master, but we don't deploy any of the pod. We can deploy, but it's not good to give any extra load to the Kubernetes master cluster. Okay, so we deployed all the things in a worker node. So we applied a taint, and we didn't pass any pod configurations with the tolerations to deploy in the master component. Okay, so for any of the nodes we want to deploy it as a we apply a taint on it, then we can deploy it with the tolerations. We have a more detailed video on the taint and tolerations as well. The Cubelet, so this is the captain, you can say, of a small ship, and the Cubelet, QProxys and container, it will exist in every node, every single node. So Cubelet is an agent that runs on each node in the Kubernetes cluster. It is responsible for the management and orchestrations of the container within the pod on that particular node. So you will find the Cubelet, QProxys and the container will exist in every particular node. So what is the key functionality? The pod executions, okay, the container health monitoring, resource allocations, volume mounting, and the pod lifecycle management. Cubelet is responsible for the entire lifecycle of the pod, including creating, starting, stopping, deleting. Suppose you just put a request to the Cube API server to create a pod. At that time, the scheduler will provide the informations about which particular nodes there is availability, and the Cube API server just pass this informations to the Cubelet and registered here. Okay, so the Cubelet just confirm that we deployed this particular pod in this particular node. Okay, and then the informations it passed to the Cube API server, and then Cube API confirm the etcd that it's already deployed. So it will register all the informations on which node. So in this way, the communications happen between the Cubelet of a particular node through the Cube API and then the etcd. Okay, communications with the control plane, we already discussed it. QProxys, it used for the any types of network communications within a node, between the two nodes. Okay, so QProxy is a network proxy that run on each node in the Kubernetes cluster. Okay, the key functionality is the service discovery, load balancing, network address translation, pod to pod communication, the firewall rules. So QProxys configured network rules. Okay, so IP tables or IPVS rules to enforce the network policies and security rules specified in the Kubernetes network policies. The container runtime, the popular one is the Docker, and you will find the Docker everywhere that is used as the Open Container Initiative, OCI. Okay, so key functionality of this is container lifecycle. Okay, isolations, resource management, image management, networking, and the storage. So these all three things will be available in each node: Cubelet, QProxy, and the container runtime. Either you use the container D or the Docker. Okay, so Docker will be the popular one, so you should have the knowledge of the Dockers. how to see the logs, and how to track all the things like the volume mounting and all these things, basic things you needs to be have a clarity before jumping into the, because at the end you are just deploying your applications inside a container. Okay, the pod have the container, and the container holds your applications, and the container is a Docker. So you must have the basic at least knowledge of the Docker to understand the Kubernetes cluster in more details. So hope you like my video. If you didn't subscribe my channel yet, please do subscribe it always motivate me. Share the channel link with your friends. Have a nice day. Thanks.